Okay, we've got tab 2 of the trigonometry missing angles exercise. It's got 3 questions on it. Let's have a look at the first one. Okay, so I've drawn it rather badly, I have to say, on my pad, but it's got an isosceles triangle. So it says in the question, ABC is an isosceles triangle with AB equal to AC. So that's 13. That's 13 as well. It's also got the little markers to remind you that they're equal. And then the other thing with an isosceles triangle is that it has 2 equal angles. So they tell us that that's x the other side as well. And then when you drop a vertical line down the middle of an isosceles triangle, it splits it into 2 right-angled triangles. So we've got 2 right-angled triangles there that are exact reflections of one another. So if that's 11 along the bottom, then it splits it into 5.5 and 5.5. So if we're trying to find out what x is, we only really need to bother about the right angle triangle. So rubbing half of it out, we've got x, we've got the side 13 here, which is the hypotenuse, because it's the longest side, not just because it looks longest, but because it's across from the 90-degree angle. So the 13 is the hypotenuse. The 5.5 is next to the x, but it's not the hypotenuse. That's the adjacent meaning next to, and then we're not going to use the opposite side. So we're looking for the trig ratio that has adjacent and hypotenuse. So that's cos equals adjacent over hypotenuse generally, and in this particular case the cos of x is equal to adjacent over hypotenuse 5.5 divided by 13. So we want to know what x is on its own. So we need to kind of uncos the left hand side, and then we need to uncos the right hand side as well to be doing the same thing to both sides. So x isn't just the cos of 5.5 over 13. X is the angle that when you do the cos function to it gives you the answer of 5.5 over 13. So the reverse cos function is called arc cos. So we're looking for the arc cos of 5.5 over 13, and I can do that on my calculator. So let's get the calculator on there, turn it on, clear all the old stuff. So I go shift cos for arc cos. It writes it as a little cos with a -1, which I've never liked. So the inverse cos or arc cos of, it's opened the brackets for me, 5.5 divided by 13. I'll close the brackets and press equals, and it gives me 64.9 degrees. So to the nearest whole degree, that's 65 degrees. So I'll just fill that in on the iMath screen. 65 degrees. Okay, the next question says ABCD is a rectangle. My diagram doesn't quite look the same as the one on the screen. It's a little shorter and fatter, but it doesn't really matter. It's representing what's going on in the question. It's not supposed to be a scale drawing. We're not going to get the answers by measuring the diagram. So anyway, it's got 19 up the side there and 15 along the bottom there, and having these diagonal lines splits the rectangle into lots of isosceles triangles. So because that's the same as that and that's the same as that, then this triangle is isosceles and it's just a reflection of this one on the other side. And then top and bottom we've got 2 different or 2 more isosceles triangles that are different from these but the same as each other. So because it's an isosceles triangle, I can split it down the middle and get a right angle triangle. So if that was 15 along the bottom, then it's 15 along the top, and that red line that I've just drawn splits into 7.5 and another 7.5. So 7.5 there, half of 15, and then vertically the whole rectangle is 19, so that half of it, the red line, is half of 19, 9.5. So the angle I'm trying to find is the x here. If I just kind of get rid of everything that's not part of a right angled triangle, then the angle I'm left with in this triangle, it's not the x, but it's only half of it. So I'm going to call that y. So y equals a half of x, and we're going to try and figure out what y is first, and then we'll double it to find what x was. So in the triangle that I'm left with, I'm trying to find out the angle y. I've got the opposite side to the y, 7.5. I've got the adjacent side to the y, 9.5, and then the other side is the hypotenuse. We know it's the hypotenuse because it's the longest side. We know it's the longest side because it's opposite the biggest angle. So opposite and adjacent, that's going to be tan. Let me just get a different pen for that. So tan of y is going to be opposite over adjacent, 7.5 over 9.5, and then y itself is going to be not the tan of 7.5 over 9.5, but we want to untan it, so it's going to be the arctan of 7.5 over 9.5. So I can get the calculator on that. So shift tan, open brackets, let's try and get that in the right light so we can see it. Shift tan, open brackets, 7.5 divided by 9.5, close brackets, equals 38.29. But remember that that was only half of the angle we were trying to get, because we were trying to get the bigger x that was double that. So x equals 2 times that, 2 times arctan of 7.5 over 9.5, which gone off the screen there. But basically that times 2, so I'll just multiply it by 2, and I get 76.58, so just about 77 when I round it to the nearest whole number. 77. Right, here's the last question. It says ABC is a right angled triangle. D lies on BC and DC equals DB. So it's telling you that those two are equal, and then in the diagram in the question it's got 2 little markers to remind you of that fact. And then it also says that BC equals 19 centimeters. So if that's 19 centimeters and it's telling you that those two are equal, then it's telling you that those are 9.5 each. It's telling you that the line AD is splitting this line in 2, and then it tells you that the angle in here is x, and that's what we've got to try and find out. But the trap you might fall into is thinking that that should also be x as well, but that's not necessarily true. So just because that divides that line in 2 doesn't mean that it divides this angle in 2. And our job is to find that angle x, and you can see I've drawn 2 more triangles, and that's because this original diagram has 2 triangles in it, a big one and a small one, and I'm going to split the problem up into the 2 triangles. So I'm going to call that, well, that is 28 there. They're all 28 on the base. They're all right angle triangles. This one's 9.5 at the bottom, or sorry, at the side as it was before, and this is the full 19. I'm going to try and find out this angle in here. in the big triangle, I'm going to try and find out this angle here in the little triangle, and the x that we're trying to find out should be the difference between the two, because it's that whole big angle. Take away that bit, leave you with the x. So that's the idea of this. I'm going to call these randomly, I'll call them angle J and angle K, just to give them names. So we have got, in relation to J, the opposite and the adjacent. We've got, in relation to K, the opposite and the adjacent, although it's a different opposite to in that triangle. So opposite and adjacent is tan, so tan of J equals opposite over adjacent 19 over 28, and J itself is the inverse tan or arc tan of 19 over 28. Let's go for a different colour now. K, so let's just colour that blue. So tan K equals opposite over adjacent 9.5 over 28. And then K itself is going to be the arctan of 9.5 over 28. And then the angle that we're trying to find out is just the difference between that and that. So x is equal to, let's rub out all the other stuff, x is equal to arctan of 19 over 28 minus arctan of 9.5 over 28. I realise that's a bit difficult to read, but if you followed the video along, it says 9.5 over 28. So I can get that into the calculator, and I'll try and put it in one big calculation. So shift tan 19 divided by 28 close brackets minus shift tan 9.5 over 28 close brackets equals 15.41, so 15 to the nearest whole degree. So just putting that on iMaths, 15, let's mark it, 9 out of 9.